Okay, we are welcome to our continuation of Docker. Today we are going to be looking at a very important lesson in Docker. Can everybody see my screen?
Yes, sir.
Yes, sir.
Okay. We are going to be looking at a very important topic in Docker, which is called Docker Swarm. Now, if anybody ever asks you that what is Docker Swarm? If anybody ever asks you that what is Docker Swarm, tell the person that Docker Swarm is an orchestration tool. Docker Swarm is an orchestration tool. Okay, this is what we are talking about. Docker Swarm. I think there is a problem with my sharing. Okay. This is what we are talking about. Docker Swarm, right? If anybody asks you what is Docker Swarm, Docker Swarm is an orchestration tool. The next question is, what is orchestration? What is orchestration? That's the next question. If you say Docker Swarm is an orchestration tool, so what is orchestration? Okay, let's get back to our design board. Now, look at the theory behind orchestration very well. Please follow up very, very well. If you don't follow up the underground theory behind orchestration, you are going to fail. Now, every computer that you have, right? Every computer runs a Docker engine. Okay? So this Docker engine helps you to run Docker containers. You can run as many containers as possible, right? Okay. Question is, what is a container? What is this particular container like this? What is a container? A container is a micro independent functionality of the application, right? This is the app. This is the application. Okay, which this application can run in one container alone. In one container. Okay, now if this application can run in one container alone, so why is the need to make 2, 3 containers? Because I have a website. My website is deployed in Tomcat. In this application here, like this Tomcat. This application is a Tomcat website application. My website is deployed in this Tomcat. People can access my website through this Tomcat. Why will I need a second container for this particular Tomcat? The same Tomcat application. Why will I need a second container? That is a question, right? The answer is that as many people are accessing this Tomcat container, like this, the processing capacity of this container like this becomes limited. When it becomes limited, what will happen? We want that as many people continue to access the application, let some traffic start flowing to this other one, this other container like this. And if the people keep on increasing, let the traffic flow to this other one. Right? That is what we want. This Tomcat container and this one are all the same. They have the same information. Okay? That means the first Tomcat container has the same website like the second Tomcat container, like the third Tomcat container. For example, if you enter, let's take any website, for example, if you enter google.com, you are going to enter a particular container, right? But if somebody in India is entering google.com, he might enter a different container, but the same information is found in all the two containers. It is the same website. Okay, so the need for the increase of containers is so that it can save as many traffic as possible. That is the reason for the increase of containers. Is the increase of containers infinite? What do I mean by infinite? That means, can I keep on increasing my containers forever? Can I keep on increasing my containers forever? Even in drawing, you see that at one particular moment, our system is full. Is that true? At one particular moment, our system is full. When our system is full, what is the first thing? Where were we? We were in this computer, in one computer, computer 1. We were in computer 1. Computer 1 is already full, but there are still so many people that want to be accessing our application. So many people from the whole world that want to be accessing our application. But what is happening? This computer is full. What do we do now? The next thing that we are supposed to do is we want to add the second computer. We want to add the second computer. And in the second computer, we want to still continue adding our containers. Our containers keep on adding, keep on adding, keep on adding, keep on adding. Now, the containers that are added to this computer and maybe another computer, the containers that are added to this computer and maybe this other computer, all have the same information. Now, that means that what? If traffic is coming from the internet, that traffic can be sent anywhere, either here, here, or to this other computer. The traffic can be sent anywhere. And if the traffic is sent here, it can be sent to this container, this it can be sent to either this container, this container, this container, or this container. Or it can also be sent to this container, or in worst case, this container. Or it can also be sent to any other container. So you discover that what? It is now possible that all these containers like this can coexist together. So the coexisting of containers together in different computers is what we call orchestration. Orchestration. The coexisting of containers in different computers and they are collaborating together is what we call orchestration. So Docker Swarm is an orchestration tool. What is orchestration? Orchestration is the coexisting of microservices in different platforms, in different instances, in different computing services. That is orchestration. Is it okay at this level? Can we go ahead?
Yes, sir, it's okay by me.
Okay, fine. So, if this is orchestration by this level, how can we make, what can we do in order to make all these computers have different containers and collaborate together and communicate together? How can we do that? We are going to do that with what we have in our study today. Orchestration is all about load balancing, scaling containers, performing rolling updates, and handling failovers. Okay, so we are going to see how we can add and remove nodes from Docker. Okay, so generally the structure of Docker is this. The structure of Docker is this. In Docker, we have a structure that follows this dynamics. We have the master instance. This is the main instance that control all the other instances. The master instance, we call it the master. And then we have the workers. These are the workers. So this is worker 1 and this is worker 2. So what will happen? We will never be installing applications in these workers. All our applications are installed in the master. And as we are installing application in the master now decides where these applications are installed. The master can install applications in any of its workers. We install the application in the master decides where the application, where the number of containers are going to run. Okay, so in order to make a master, we are going to install the following in the master. We are going to install, number 1, we are going to install Docker in the master, and then we are going to make the master to be master. We are going to name master. In worker, we are only going to install Docker, and then we join worker to master. In worker 2, what we are going to do is install Docker, and then we are also going to join worker to master. That is the job that we are going to do today. We create one EC2 3 EC2 instance. You can create as many as you want depending on the load that you are going to, you think that you can support. You create 3 EC2 instance. In one EC2 instance, you are going to make it master. The second EC2, the 2 EC2 instance, you are going to make them workers. Worker 1, worker 2. Is worker 2, please. Okay, this one should be worker 2. So that is the job that we are going to do. So we hit over to our system. Now we are back to AWS, because you cannot do this one with your normal systems, right? We hit back to our system. Now we launch 3 instances. Keep them T2 micro. Take my key pair. Select my security group. You make sure that you allow all traffic in your security group, or else it is going to worry you. And launch my instance. Okay, I have my 3 instances. I keep the first one as master. I take the second one as worker 1 and the other one as worker 2. Good. Now the first one is worker 1, the second one is worker 2. Okay, the next thing I want to do is when I enter these EC2 instances, look at what will happen. I want to log into this instance. I want to log into this instance. Okay, look at what happens. When I log into this instance, what I'm seeing here is Ubuntu and then the IP address. But what I want is, I don't want to be seeing Ubuntu and then the IP address. I want that, because I'm going to be working with 3 computers. I don't know which one will be master, which one will be node. So you can confuse between master and node and all the like. Okay. In order not to confuse between master and node, I want to name my own computer inside the system as master. Okay, where is the name of this computer found? Where is this IP place found? It is found in a place called ect/hostname. There's a file that carries it. The file is found here, please. You go to, if I just go to cd into etc and I say ls, you will see a file called host name, right? Host name. If I open that file, host name v, you will see this here, right? That is the same thing that we saw there. So if we can change this one from all this into master and then we save, now this root at this will now turn into master. How will it turn into master? You have to reboot your system. How do you reboot your system? The easiest way to reboot your system is init 6. Your system will get rebooted. Okay, when you get rebooted, you try to log in again. Let's try to log in again to see how our system has changed. It needs to take some time to reboot. So by the time it will reboot, you have some patience for the system to reboot. While it is rebooting, we are going to do for the other worker 1 and worker 2. Okay, you see how the system is now. We have master here. So with this now, I cannot confuse whether I am in the master or I am in the worker 1 or worker 2. I am very certain now that I am in master because I have seen Ubuntu at master, no more the IP address that is here. Okay, now the same thing is going to be done at the level of workers, so that I know whether I'm in worker 1 or worker 2. If you don't do this, you are really going to get highly confused. Why is my worker 1 still pending? It's a problem. Let me do it for worker 2. Worker 1 is pending, which I doubt I signal a problem there. It's not supposed to be pending. Okay, I do the same thing here. And then I open the file. I can open the file directly, right? You can open the file. You already know where the file is, so you can open the file directly. And then, is it the file? No, this is not the file. Host name. There was an N that I did not put there. Host name. Now that is the file. So I can change it now to worker 2. Then I reboot. Don't know why my worker 1 here is refusing to come on. Why should it be pending? There's a problem with this worker node. Okay, let us terminate it and create another one. Worker 1. This is the worker 1 that we have just created. We have terminated this other one. I hope this one will come on. Good, it is on now. We use this one. We enter the host name. Then we configure this into worker 1. And we save. Now we run init 6. We try to log in. So now this is worker 1, this is worker 2, okay, you see it is written here worker 2 now very clearly. Okay, written there worker 2. So let's try to launch with this one. And this is written now here worker 1. So we have our arrangement like this. This is worker 1, this is worker 2, and then where is our master? This is our master. All right, so all we want to orchestrate all these three instances: master, this is master here, worker 1 here, and worker 2 here. So how this one is not yet master, just by naming it master it is not yet master. How do we make it master? In order to make it master, first thing is we install Docker inside. So how do we install Docker? We have our Docker script. You have your Docker script and you know how to install Docker. I'm going to use the other small version of this script. This is my script. The first one downloads Docker and then the second one installs Docker. Okay, so this is the script I'm using. For my master, I'm installing Docker. Okay, now let me install Docker. I create my script. I save my script. Now I run my script.
You want also. You make double O.
Exactly. So while it is executing in master, we go and try to install the same thing in worker 1. This should be worker 1. In worker 1, this worker 2, it doesn't matter. In worker 2, we create the same file. Let's put it doc2, and then we create our file there. Then we execute it. While it is executing, we move over to our worker 1. You see here it is easy and you cannot easily get confused because you are having all of them named. This is worker 1. You can work in confusion. If you want to hypnotize people that you are an IT engineer, you can populate your screen with all this nonsense. Some people enjoy that. Just making the screen dark and
locks are going up and down.
unnecessary locks are going up and down.
and you go for washroom.
Okay, all our 3 machines are installing Docker. Let's come back to our first machine that has installed Docker and finished. So this machine has installed Docker and has finished, right? Now, as it has installed Docker and is already okay, we are in the master. We have to now make the master to become master. Okay, we make the master to become master. How do you make the master to become master? This is an interview question. How do you make, what do you do in order to make an EC2 to become a master in a Docker swarm? Okay, you run a command. And what command do you run? This is a command you run. You initialize the swarm. You make a Docker swarm init. Okay, you run the Docker swarm init. So if they ever ask you in an interview question, what do you do with an EC2 to make it become the master? You say you run the Docker swarm init. Okay, you run the Docker swarm init. And now this IP address should be the IP address of the private IP address of your machine that is going to be master. So let's go to our machine that is master and see the private IP address of that machine. This is our machine that is master. This is the private IP address of that machine. We copy the private IP address and then we replace it here. And then we run the Docker swarm init. Okay. When we run this Docker swarm init --advertise /add this address, it is going to become master. Let us see. Make sure that this IP belongs to this machine. You see, swarm initialized current node, right, is now a manager. That means it is now the master node. It is now a manager. Look at this this statement here. Swarm is now initialized. Current node is now a manager. Now look at this information here. To add a worker to this swarm, run the following command. They will give you that command. This is the command you have to run. So now you take this command like this and you are going to run this command in the other 2 nodes, so that they will join now to this one and become a worker node. Okay, we copy the command, we go to the other 2 nodes. We go to this node. We know that this node is already having Docker installed, so we can run now the command for the node to become a worker under Docker. Okay, we paste our command. You see what is happening? This node joined a swarm as a worker. That means the node is already there. We go to the other node. We paste our command again. What did I do? All right, I'm sure we are at the beginning. This node joined a swarm as worker. We are good. We are good. Let's come back to the master now. We know now that everything will be happening at the level of the master. Everything happens here. So in the master, the first thing we can do is let's run docker node ls. I think when you run docker node ls, what do you see? You see all your node. You see the master is there, the worker is there, the worker 1 is there, the worker 2 is there. All of them are ready. Okay, all of them are ready. So what are we having in effect now? What have we just created? We have created a service in this dimension. We have created a service in this dimension. It runs now like this. This service runs like that. So we can install now applications in any of these services and they are going to run together. This is the foundation of microservices. This is the underlying mechanism of microservices. The services now are going to be running in 3 computers but behaving as if they are running in 1 computer. You see the idea? All the service that we are going to be serving the world with it, they are going to be running in 3 different computers, but they are going to be behaving as if they are running in 1 computer. What are the advantages of doing it like this? The advantages is that we can add as many computers as we want, that is scaling out. We can also increase the capacity of the computers that we have, that is scaling up. So we have scaling out, that is adding computers to this thing, which we call it horizontal scaling, or scaling up, that is adding the capacity of this computer, which we call it vertical scaling. So in this way, we can also scale down, that is reducing the number of the computers that are available, and we can also scale scale in. Scale in is reducing the number of the computers that are available, and scale down is reducing the capacity of the computing capacity of our computers. That is scaling down. So this gives us now this elasticity of, if the traffic increase, we scale out. If the traffic reduce, we scale in. If the traffic increase, we scale out. If it reduces, we scale in. That gives you that elasticity that the cloud is out there to offer. So that you should not have 20 computers. When those 20 computers, you are there paying money for 20 computers when you actually indeed only need 2 computers. Imagine that you created a data center and then you have all those computers installed in it, but your traffic only can serve you 2-3 computers, but you are having almost close to 20 computers there. All those that's you wastage. So that is one great aspect of the cloud, which is elasticity. Microservice comes to make greater use of that elasticity with its containerized nature. Okay, so right now, yes, decline is still joining. It's dangerous. Okay, right now let us actually see the working of containerized applications in reality. Okay, we are going to install an application in master without installing it in worker 1 or worker 2, and that application will run in all of them. Okay, here is where we start. Okay, let us install Nginx. No, Tomcat. Let us install Tomcat and see how it functions. Okay. Now you might see a difference in the way you install applications, which is different from what you used to do with your normal containers. Look at this. Look at this command. Docker service create. Look at it very well. Docker service create. What is the difference between running a container in a single computer and running a container in a service? Is you change the name from Docker run to Docker service create. That is a big difference that you can see there. Now, another thing that you will see there is, all this hyphen hyphen name hyphen hyphen, you are giving the port, but what you are going to see new here is this replicas. Replicas, what is the meaning of this? Instead of launching one container, we are going to launch 5 different containers of the same web server Tomcat. We are going to launch 5 different containers. But launching these 5 different containers, we will not even know where those containers are going to be launched. We are just going to we say we want 5 containers. It is the Docker service that is going to decide in which particular computer that they are going to launch any of those 5 different containers. But with one command, we want to launch all these containers. I hope we understand this command very well. We copy the command and we go to our master. Make sure you launch in the master. You are launching in master. Always take care. Make sure the master is there. So we launch. It's bullshit. Okay, progress 0 out of 5 tasks. So we have 5 tasks. That means we have to install 5 different containers. So preparing, starting, running, waiting 4 seconds to be ready. Our containers are ready. All our containers are ready. Question, we want to see where those containers were installed. Where were all these containers installed? Right? We want to see. There is a command to see where the containers were installed. You run this command, Docker service ps, then you give your container name. All the containers have the same name. Docker service ps. This is the command that you run. Docker service ps, then look at this container name here is the same one that you are giving here. All right, Docker service ps. Now when you run this, you see that the web server 1, web server 2, web server 3, web server 4, web server 5, all of them are running, right? All of them are in the running state. Where are they running? They are running in the worker 2, worker 1, worker 2, worker 1, right? All of them are running in different we have 2 workers. Worker 2 is having 2 of them, worker 1 is having 2 of them, and then the master is having 1 of them. So here is how they have been positioned by the master. Here is the way they have been positioned. This one says I am taking 1 container, this one takes 2 containers, and then this one takes 2 containers. That's how they have been positioned. But all of them, they are acting as if they are in one computer. So how can you access them? Can we access them that like we access our normal computers? Yes, we can access them. Look at the command that you run and see how you can access them. What did you do? You did a port binding from 8080 to 1990. So that means if you take the public IP of the master, if you take the public IP of the master and you bind it here with port 1990, you are going to see Tomcat. That's what we expect. Yeah, that's Tomcat. Now, to show that you can access any of them, let us take the port IP of also any of the workers. Let's take worker 1. We take the port IP of worker 1. Yeah, okay, this one is terminated. This is worker 1. Public IP of worker 1. We put there. And we put 1990. We still have our the same application that is running in manager is the same application that is running in worker 1. We can still do the same for worker 2. Right? We take the port IP for worker 2. So you see, this is the manager, the main master node. This is worker 1, a worker to the manager. This is worker 2, but all of them are having the same information, the same application, because we launch only one application. That's the meaning of orchestration. That is what we call orchestration. Okay, so in our class on Monday, we are going to look at how we can do what they call scaling out. How can we add more nodes to our swarm, and how can we add the computing capacity of the computers in our swarm? How can we also add so many containers in our swarm? Because at this particular moment we have only 5 replicas. Can we add 10 replicas? Can we add 20 replicas? And can we also reduce from those 20 replicas to by 4 replicas or to 3 replicas? Can we do all that? We are going to see it in our Monday class. Any question?